Hello, welcome back to another video looking at functions for mathematics grade 12 paper 1. So today we'll be looking at question 6 from November 2018. So let's get started. So it says in the diagram below, A and B are the x-intercepts of the graph of f of x is equal to is equal to x to the power 2 minus 2x minus 3. A straight line G through A cuts f at C. So this is our straight line G, and this parabola is our function f, right? It cuts f at C. It also has the cuts f at C, and the y-axis at 0 and 1. So this is our y-axis, which is 0 and 1. So this is our y-intercept. M is a point on F, that is M, and N is a point on G, and this is your point N, right? So it says such that MN is parallel to the y-axis. So these two parallel to each other. Well, these ones parallel to each other, the y-axis and mn. So this is actually a straight line, which means that the x value at n is the same value at m, right? So it says mn cuts through the x-axis at t. So this is t. It means we have the same x value on this side for n, t, and m, just different y values, and the t we just have 0 because it's on the x-axis. So we're done with looking at the graph. So let's just look at the question. So it says that show that g of x is equal to x plus 1, right? How can we show that? We have those two values. We can calculate the gradient, and we already know that the y-intercept is 1. So we can just start working on that. So let's see. So low. Okay. Some technical problems, but got it sorted out now. Okay, let's start with our solutions. So this will be 6.1. So we're required to prove that g of x is equal to x plus 1, right? So let's start with the gradient. We know this is y2 minus y1, x2 minus x1, right? So we can just put this. So what is the 4 and 5 for C? So we can have 5 minus 1, that's the y-intercept, and then 4 minus 0, this will be what? 4 over 4. Therefore m is equal to 1. The equation of a straight line, we can write that as y1 is equal to m x x1. So we have y minus 1. Oh yeah, we can. It's very simple because we already know the y-intercept, so we can just write y is equal to x plus 1, right? So we got that. That's our g of x. 6.2. So this we know it because we're given on the graph, right? It's that one there. So calculate the coordinates of A and B. These are the coordinates of f of x. So these are x-intercepts. So we can just say y is equal to 0. What is that y? That y is x squared minus 2x minus 3 is equal to 0. We can factorize this by writing minus 3, right? X plus 1. So we can, this is factorization. You can use quadratic formula here to get your x values. It's okay. I just think that factorization is very fast. It's faster than quadratic formula. As you can see here, you can just start saying now that minus 3 is equal to 0, or x plus 1 is equal to 0. Therefore, x is equal to 3, or x is equal to minus 1. So you can tell which one is a and which one is b. So this will be your minus 1 and 0, and your b will be what? 3 and 0. Right, those are your coordinates. So let's move to 6.3 very fast. So 6.3 wants us to determine the range of f, right? So when you're dealing with a quadratic function, so for example, something like this, let's try and draw a nicer one, or something like this, right? So we know that let's say this is P and Q at the turning points. Here, this is what P and Q, right? We know that A is greater than 0 if it's a U, and A is less than 0 if it's an N. So if it's a U, in this case, your range will be Y is an element of real numbers, Y is greater or equal to Q, because it's all Y values that are defined. They're only defined from here and up. But for this one, they're defined from there and down, because you have nothing at the top here, you have nothing at the bottom, right? So for this one, the range will be Y is an element of all real numbers or real values, but Y is less or equal to Q. We also include that because that's our Y values at the turning point, right? In this case, we have a U shape, right? We need to find the Y value at the turning point. How can we do that? Let's get started. Sorry, I want to change a pen. Yes. So fx is equal to minus b over 2a. We know that that's the formula of x value at the turning point. Minus b, that's minus 2. 2 multiplied by 1. So this will be a 2 over 2. Therefore, x is equal to 1. So let's see. We also know that you can also find this x value by finding the average of the x-intercepts. So we had minus 1 plus 3. You can divide this by 2. So this is 2 over 2. So this is 1. So yeah, checks out. That's correct, right? So let's see. Let's just trace back our steps. All right. So we found one, makes sense. So let's see. We're just trying to see if we didn't make any mistakes, right? So the Y value is f of 1, which will be 1 squared, 1, 3, minus 2, minus 3, which is equal to minus, oh, actually it's this. It's going to be minus 4, right? Because you have 1 minus 2 minus 3. So 1 minus 5. Therefore, y is equal to minus 4. So your range will be what? Y is an element of real numbers, but y is what? It's greater or equal to minus 4. So that's your range there. Alright. So let's just, because this was our question, so we needed to answer this. And we got there. So let's just go to 6.4. I think we're on 6.4, if I'm not mistaken. Yes. So 6.4 wants us, it says that if mn is equal to 6, determine the length of OT if t lies on the negative axis, show all your workings. So what I was told, what we're given that mn is equal to 6, right? This lies on f, this lies on g. So we can just say fy of f minus y of g is equal to 6, right? That's what it means. So this distance here, when you find the difference, should give you 6. So let's just substitute minus our, let's just subtract our formulas. So we can say f of x minus g of x, which is m of n, which is mn, should give what, 6, right? So we'll say x squared minus 2x minus 3 minus x plus 1 should give you 6. So we have x squared minus 2x minus 3 minus x minus 1, okay, should give you 6. We can take this side, so we have x squared minus and minus, minus 3x minus 4 minus 6 equal to 0, right? Because this is minus, so you will have x squared 3x minus 10 is equal to 0. So let's see, can I factorize this very fast? Yes, I can. So x minus 5 x plus 2 equal to 0. This is actually a scale that you build over time by factorizing many equations, right? You can look at what so what you do when you want to factorize very fast, you just look at this and look at this. Is there a way that you can find two fractions that if you multiply them they give you this minus 10, when you add them they give you this minus 3, right? That's what you're looking for. And I have this plus them, I get this, multiply them, I get that. So I have x minus 5 is equal to 0, or x plus 2 is equal to 0, right? Therefore, x is equal to 5, or x is equal to minus 2. Okay, so we got that. So let's just look on our graph. We already know that t will be minus 2, right? Makes sense because this is minus 1 and this distance is somehow similar, right? So we can be confident that that's actually our answer at minus 2, right? So we can just say crash there, NA, right? So what did we want? We wanted the length of OT, which is from here to here. So okay, we know that OT will be our 2 units. Therefore, OT is equal to 2 units, because distance doesn't have a sign, right? It's just distance, not displacement, just distance. It's a scalar. So 6.6, if it was a displacement, which is a vector, it will have a quantity and what and a scalar. So it could be minus 2, which means that it's in a specific direction, right? So we're only dealing with scalar here. 6.5, oh sorry, we're still on 6.4. This is just 6.4.2, so it's a follow-up question, I think. So I can write this as 6.4.1 and then just write 6.4 here. Okay, what does 6.4.2 say? It says has, write down the coordinates of n. And we don't know its y value, we know its x value because it's on the same line as t, so it will have x is equal to minus t2. So let's just what, it's f n nice on g, so we can find y by just substituting 2 to g, right? Minus 2 to g, so it just have minus 2. This will be minus 2 plus 1, which is minus 1. Therefore, n is minus 2. So let's confirm that this is n, it's on g, that's for sure, which is x plus 1, and the x value is minus 2. Substitute into here, minus 2 plus 1, that's minus 1. Kind of makes sense, right? So let's just move. We have determined that yes, 6.4.2. So let's go to 6.5. It says determine the equation of tangent to F drawn parallel to G. Okay, so let's work a little bit here. So what I want us to do is a tangent. Actually, we know that a tangent is a line, a straight line that touches a function at one point, or a graph at one point. So for example, let's do that. This is a tangent, right? This, oh no, let's make it like that. Yes, this is also a tangent, right? So a tangent is a line that touches the graph only at one point. So the point of intersection between the graph and the line is 1, right? You don't have many points of intersection. So for example, this is not a tangent, that's a secant, right? So let's look at it like this. We want a tangent that is perpendicular to this, which is tangential to F, right? So we can draw it like this. Let's just find the line here somewhere. Let me just do this, then I'll try to place it very well. Let's see. Yes. I grabbed it. Let's move it a little bit. Okay. Let's just do this. Yes. And then I can also push it a little bit here. It's yes. So we have this. So we can just say these two are parallel, right? What do we know about parallel lines? So if you go back to analytical geometry, this is where we talk about parallel lines a lot. We know that let's just go back here and write let's just use a blue one. So parallel lines have equal gradient. Have equal gradients, right? Therefore, tangent line to F, its gradient is equal to 1, which is equal to the gradient of G, right? So it is a gradient of 1, okay? So let's look at it like this, right? This is our function. Let me just write somewhere, draw a better function. So I don't want us to go back there now. I want us to focus here, right? So we have I'm gonna draw a triangle, a tangent. So this is our tangent, right? We're not really sure where it touches. So the misconception would be to say maybe it touches the tangent at the turning point, but we don't know that, so we don't assume that, right? Because they specify that it's parallel to the to G, right? So let's say this is our G, right? And this is our tangent. Let's just give it H, right? Let's just define it as H. It's much better to do that. So let's say, for example, yes, it's H, right? So let's do this. How can we find the gradient of F? Cause at when the turning point of F and H, right, we know that the gradient is equal to 1 because it's the gradient of H. But what is the gradient of F? Because it's also crossing there. We know, so let's just do this like that, like this. F of x is equal to x squared minus 2x minus 3. The gradient formula, this is the formula of the gradient. It's 2x minus 2. This is differentiation, right? You say 2 by 1 and then you say 2 minus 1. 1 by 2 and then 1 minus 1, that's 0. X to the power 0 is 1, so that's why you have this. So we know that the function f has a gradient of 2x minus 2 at this point 2, right? So we can equate those ones because they touch. So you just have this equal to 1, right? So you have 2x is equal to 1 plus 2, which is equal to 3. Therefore, x is equal to 3 over 2, right? So by using that gradient, we were able to find what? The x value where the line is tangential to our graph. So let's continue. By finding the x value, we can find the y value because it lies on f2, right? So the y value is what? f3 over 2, which is 1.5. So this is what? 3 over 2 squared minus 2, 3 over 2 minus 3. I can say, so that's what? 9 over 4. So this is minus what? So 2 and 2. So I'll just have what? Minus 3 minus 3. So 9 over 4. Can just use a calculator here and not do what I'm doing, right, to save time. So 9 over 4 minus 6. So this is what? 9 over 4 minus 24 over 4, which would still give you 6. So you just have what? 9 minus 24. If you were to minus 10, you will get 14. So since you are minus 9, you get 15. So that's 15 over 4. If you use a calculator, it will give you the same thing. So what do we have? We have 15 over 4 and 3 over 2, right? So now we have a point. This is the point of intersection. So the point of intersection of f of x and that tangent is what? 3 over 2 and 15 over 4. So what did they want us to calculate? They wanted us to determine what? The equation. We now have a gradient, which is 1. We have the point of intersection, right? So what we can do is we can say y minus y is equal to m, and then you have x1. So y is this is also an equation that's mostly used in analytical geometry. So it's very important to be well versed in paper 1 and paper 2. It is very helpful. It makes you to see these things much clearer, so you don't have to struggle, right? So let's just take this 15 over 4. So let's see, x minus, how can I do this? I can make this 4 by multiplying both sides by 2 up and bottom. So I have 2, so I have 6 over 4 plus 15 over 4 y is equal to x minus 6, so that would be 9 over 4. So this is the equation of our gradient, right? So we can just use a calculator to confirm that. Yes, it is 9 over 4. So let's just confirm this 15 over 4. 3 over 2 to the power 2 minus 2, 3 over 2 minus 3. Yes, it is minus 15 over 4. Oh, yeah. Why did I think that it was a positive actually? I don't know why, because this minus 9 minus 24 should give you a negative, right? So yeah, but it's better that now I know that this is definitely what I think it is, because I've confirmed it with 2 different types of calculations, and this will become what's your negative, right? So now this will change. It will just be what? It will just be 21 actually, I think. 6 over 4 and 15 over 4, yes, should give you 21 over 4. So this will be a 21 over 4. Very good to always confirm your calculations by checking them more than once, right? Just don't do it too much because you won't finish. So, but do confirm your calculations and be confident in what you have written down. Let's see, 6.6. Okay, what does 6.6 want from us? It says, for which values of k will f of x and h not intersect? Okay, so let's go back here. Right, I'll draw something similar to what I drew before. So I have f, I have h, so that's what I did before up there, which was my tangent, right? I know this is 1. Let me actually just write m is equal to 1, right? So we want values of k which at at the y-intercept, for which this will be something like this. We'll have x over h, which is x plus k, right? We want to know what k is, for which we'll have a graph like this. What is a graph like this? A straight line. It's a straight line that doesn't touch this, right? So it's below the graph. It's this side, right? We know, for example, here, we know what the k was for this one. What was k? K is equal to minus 21 over 4, right? This is our k here. So if you want one that could, and this k here, where our line was touching the graph, if we have values of k that are less than minus 21 over 4, what so these are values that are more negative, right? Down. These ones will mean what? Will mean that your graph h is shifted down, so it won't touch what? Your function f. So what is the solution? Therefore, solution is just k is less minus 21 over 4, right? So this type of questions, right, are similar to those questions where you have f of x multiplied by g of x is greater or equal to this, or those equations where you have to find nature of roots, where you have to find k for which it's a nature of roots like this, or where you have to find k for which values of x are like this. So they're very similar. So what you need to do is to visualize what you're looking at, right? You need to visualize it. Drawing always helps me understand things, right? By drawing, I'm able to to express my thoughts, right? And then when I see them, it's like they belong to someone else, which helps me understand them more, right? So it's like I'm explaining to myself what I'm seeing, what I'm thinking about. So it's very important to draw, make sketches, write everything you know down, right? And then you discuss this information with yourself. Make it simple, right? Make it simple, very simple, even for yourself, so that even the person that's marking you will know. You see, for here, you can put this here for your answer. You don't have to put it somewhere else. Put here so that the person answering can see your thoughts, right? Instead of just writing an answer, which will be correct, but when you do this, it gives the person some idea or confidence, and that you some idea that you have confidence in what you're doing, right? So I rather used a lot of time, so I won't revisit what we did, but okay, yes, but we did something like this. Let me see which one was one of the most difficult ones. I think one of the most difficult questions here at 6.4, and easy to pay close attention. It's not that bad, but yeah. And then you also have 6.5 and 6.6. These ones you do need to pay attention. Sometimes you will have to watch them again and again, try to actually understand them or understand what I'm saying, right? If there's anything that you need, just drop a comment. Please like, share, and subscribe. Thank you. Until next time.